The Vitract test, it's a 16S based test where we basically identify the distribution of the different bacteria and archaea that is in your gut. But what the test gives you an insight into is it gives you an insight into your gut diversity. And when we talk about gut diversity, we're talking more about the richness of your gut, that is the total number of species that is in your gut, but how evenly spread out they are as well. Another thing that the test does for you is we give you insights into the metabolites that they might be producing. So here we're not primarily measuring the metabolites themselves because you cannot do that with the 16S test, but we can give you insight into the metabolites that your gut profile may be producing based off on your result.
This episode is brought to you by really the best way to nuke zombie cells. When you look at this buildup of senescent zombie cells in your body, it turns out that although these things churn out inflammation like, well, zombies, there's ways you can fight against them. The good folks at Neurohacker Collective are experts, and they've cracked the code at nuking these zombie cells in a safe and effective way with just 2 days a month of using their Qualia senolytic. You get a pack, take 6 capsules one day, 6 capsules the next day, set it and forget it for the next month. So if you want 15% off, the best way to nuke zombie cells, go to neurohacker.com/BGL15 and use code BGL15 for 15% off any purchase. That's NEURO hacker.com/BGL15 and use code BGL15 for 15% off of any purchase. Enjoy nuking your zombie cells. Kiss them goodbye. Well, it's no secret I like to, poop into random hot dog trays and tubes and toilet paper and swabs and send my results off to a lab to see what's going on inside my gut. So I'm constantly trying out the latest and greatest tests, in a selfless, sacrificial act of self-experimentation to let you know good ways to figure out what's going on with your gut and how you can improve your gut health. You've, of course, probably heard podcasts I've done on the gut metabolism axis and the gut brain axis and the gut immune axis. And it's no doubt that the gut is important, but testing it is an ever expanding field. So one of the recent tests that I did was called a Vitract, Vitract. I'll link to it if you want to check it out for yourself. If you go to bengreenfieldlife.com/Vitract podcast, that's Vitract podcast. But basically, they do this whole profile of the gut. And I'm going to let my guest on today's show explain to you its difference in terms of what they test for, the sensitivity of it, and what you can find out from testing your gut. So my guest on the show is Dr. Chidozie Ojobor. I do not know if I pronounced that 100% correct, but I'm just going to roll with it. He's a scientist. He's got over 15 years of research experience in bacterial genetics. He's got a bachelor's in microbiology, a Ph.D. in molecular genetics, so obviously a pretty smart cookie when it comes to decoding the gut. He's now spent a decade developing antimicrobial entities that target disease-causing bacteria in ecosystems like the gut. And he's even won a Global Citizen Award for combating drug-resistant bacteria related to cystic fibrosis. So in his lab, he studies everything from phage therapy to CRISPR technology to gastroenteritis and beyond. And today we're going to talk all things gut. So, Dr. Ojobor, what do you want me to call you for the show? Chidozie Ojobor? Do you care?
No, I don't care. You can call me Chidozie or Dozie for short. Either way is fine.
I like Dozie.
Okay.
Is that an actual nickname that you have? Dozie?
Yeah, a few of my friends actually call me that.
No. Sounds a little bit sleepy, maybe.
Yeah.
But I should probably ask you before we even dive into all things gut. What are some of the things that you do based on what you know as far as your diet or your supplement or your lifestyle regimen to take care of your gut? I'm just curious to hear from the expert what you do, knowing what you know.
Yeah. First of all, thank you for having me on your show, Ben. It's good to be here. And to your question, yeah, I do very simple things like, stay hydrated. I think that's one really easy thing everybody can do. Water, we know, plays a huge role in digestion, allows your body harvest nutrients from food properly. It also enhances gut motility, which is a very key component of your gut health. avoids constipation, and increases the consistency, enhances the consistency of the mucous lining of your gut epithelium. So I stay hydrated.
Can I ask you a quick question about hydration? Because I've kind of always wondered this. I don't know if you have the answer, but of course hydration is important. But then you also hear the age-old advice to, I think it's the 3-2-1 rule. Quit eating heavy meals 3 hours before bed. Quit drinking a lot of fluids 2 hours before bed, and then quit use of technology and stressful business activities and bright light an hour before bed, which makes pretty good sense. But the water piece, I've always wondered, how much does water leading up to bedtime influence your ability to have a nice, hydrated, slippery, easy bowel movement the next morning? Or is it just kind of how well you stayed hydrated the entire day before that next morning's poop? Does that make sense?
Yes, it does. I think it's the latter. I think it's how well you actually stay hydrated through the day, going into the next day, versus how much water that you actually drink prior to going to bed.
Yeah, that makes sense. I guess a lot of these Ayurvedic colon cleansing blends and magnesium oxide and triphala, they all tell you to drink 8 to 16 ounces of water when you take them for your bowel cleansing the next morning. But then it's a catch-22 because you wake up at, midnight and 2 a.m. and 4 a.m. to pee.
Oh, yeah. The approach I've always taken to is, I think for gut health generally is to do things in a way that is spread out versus actually doing things at specific time points, and water is one of them.
Got it. So what else besides hydration?
Eating a diverse diet. I prioritize fresh vegetables and fruits and nuts, seeds. I particularly prioritize whole foods. I grew up in Nigeria, so we are very familiar with actually doing farm to table, from direct farm to table. And that's the approach I take in my household today. So eating diverse food like that, we know that, fresh fruits and vegetables are high in fiber, and those particularly enrich the beneficial organisms in your gut and also promotes gut diversity. So I do that.
What do you think about people who are eating an all meat diet now, like this carnivore diet craze? So
the way I think about that is, as far as diet is concerned, I like to promote more like a hunter-gatherer style of eating versus like strict carnivores or strict vegan. And that's because we've seen that the people that actually have the best gut diversity are people that have a well-rounded kind of diet. So they're eating vegetables, fruits, eggs, meat here and there, but it's actually pretty much well-rounded versus just like strict carnivorous diet. But as far as what the literature says, there are interesting studies actually that have separated people into groups where you have a group eating like a primarily animal-based diet, which is what the carnivorous diet is mostly made up of today, versus the other people eating, another cohort eating a well-rounded diet. And some interesting things actually they saw in that study. In 4 days, they saw an enrichment of certain bacteria such as Bacteroides, Alistipes, and Bilophila. And these are organisms that are bioresistant. And it makes sense because your bile acids will be produced for the metabolism of lipid. But the consequence of an overgrowth of organisms like that is we know that the buildup of those kind of organisms can actually potentially lead to an overaccumulation of gases like hydrogen sulfide.
And you saw that build up in the carnivore or the omnivore diet?
The carnivore.
Okay.
Yeah, the carnivore. And so, but there are different, sides to this story, but primarily in terms of the gut health, moving towards a plant-rich diet is what we know favors your gut health.
Now, when you're doing plants yourself and you're talking about the wide variety, how much emphasis do you place on fermented plants like kimchi or sauerkraut or even yogurts or kefirs or things like that?
Yeah, huge emphasis. I think one of the fantastic, a very fantastic group that I respect, the group of Dr. Justin and Erika Sonnenberg of Stanford. They've done this fantastic study on the role of fermented foods on the gut microbiome. But this is an age-old knowledge actually. Fermented foods play a very, very key role in promoting your gut diversity. I think I personally can do more of that. I think I used to do more fermented foods when I was back home in Nigeria. Now I do more of like just including dietary fibers, but fermented foods play a huge role in promoting gut diversity.
Can a probiotic even come close? Like if you're using a probiotic, does it do as good a job as a wide variety of fermented foods if it's a well formulated probiotic?
That's a very good question. So it depends. It depends on the scenario. So in situations where you actually have zero amount of the particular strain of probiotic that you want in your gut, then it makes sense to seed first with probiotics. But the approach that actually works best is for you to feed your resident gut bacteria with the essential prebiotics to allow them bloom. But like I said, if you have zero amount of those organisms, then you have to start by seeding them first with the probiotics and then grow them with prebiotics later.
Yeah, that makes sense. When we talk more about testing, obviously we can delve into what some of this might look like from a customization and personalization standpoint.
Right.
But before we start talking about the testing, one other question about your own setup. Are you using any kind of additional supplementation or any of these popular products for the gut, whether it be magnesium for better bowel movements, or a lot of people are using an Akkermansia probiotic now for blood sugar? Are you on board with any of these supplements?
Yeah, I think some of these supplements are great. Personally, I don't use any of them, just because I personally don't have need for them. I do my gut microbiome tests quite regularly, and it looks like things are evenly and well spread out there. But absolutely, I mean, there is the pendulum Akkermansia probiotic now, which they call the GLP-1 probiotic that is there. I do have a few friends who are using those, and the outcome that they're seeing there is great. So yeah, for some people, it makes sense to supplement, but I would always go with arming your resident bacteria with the capacity to produce those metabolites versus just supplementing.
Okay, got it. Tell me about this test. This am I pronouncing that correctly? The Vitract, or is it Vitract?
Vitract.
Vitract. Okay, tell me about it.
Yeah, so the Vitract test, it's a 16S based test where we basically identify the distribution of the different bacteria and archaea that is in your gut. And I say that it's 16S. What I mean by that is every single bacteria in your gut has what we call the 16S gene. And so what we do is, but these 16S genes have variable regions that is unique to every bacteria. So by sequencing the 16S gene, we are able to identify a bacteria and then assign a particular name to that bacteria when we compare them to what we have on the reference database. So it's a 16S test. It identifies bacteria and archaea, but what the test gives you an insight into is it gives you an insight into your gut diversity. And when we talk about gut diversity, we're talking more about the richness of your gut, that is the total number of species that is in your gut, but how evenly spread out they are as well. Another thing that the test does for you is we give you insights into the metabolites that they might be producing. So here we're not primarily measuring the metabolites themselves, because you cannot do that with the 16S test. But we can give you insight into the metabolites that your gut profile may be produced in based off on your result. And an interesting thing that will also give insights to different biomarkers. If you're thinking about a dysbiosis test, then the Vitract test is the test you should be using, because when you talk about dysbiosis, you're talking about the total composition of what's in your gut. You want to have a sense of the total composition of what's in your gut. You want to have a sense of their relative abundance and how spread out they are. And that's one of the things that this test caters to.
So if you're not actually measuring metabolites that the bacteria in the gut are producing, how do you actually know what metabolites you're seeing on a test?
Yeah, it's a good question. So what we are reporting on the test is not the metabolite, but we are reporting the metabolite producers. And so take short-chain fatty acid, for example. The way to actually measure short-chain fatty acids is if you are using like metabolomics method techniques where, mass spectrometry, where you can particularly identify that metabolite that has been produced and then quantify them. But what we are doing is upstream of that. we are giving you a sense of the potential amount of the metabolite that may be produced in your gut based off on the abundance of the organisms that we know in academic literature actually produces those metabolites.
Okay, got it. Yeah, so it's kind of like you know what these bacteria are going to produce. So once you know what the bacteria are, you know what metabolites someone could be producing.
Exactly.
Now, how is this any different? It's kind of confusing to people, honestly, from other gut tests out there. Because, for example, I've recommended a lot the Genova Diagnostics 3-day stool panel.
Right.
Viome is another very popular company. Thorne, I know they're doing at-home gut tests. It used to be, I think, Longevity. I think now it's just called Thorne. But how is Vitract any different?
Yeah, good question. So the Vitract test gives you, if you are interested in gut dysbiosis versus, just looking at a pathogenic deep dive, then you should be doing a Vitract test. I'll take an example from one of the companies that you mentioned, Genova or GI Map. Those are great tests too, but those tests primarily cater to if you're interested in a pathogenic deep dive, and that's because they use quantitative PCR to identify the bacteria in your gut.
You said PCR, so they're not using 16S sequencing. They're using what's PCR stand for again?
Yeah, polymerase chain reaction.
Yeah, polymerase chain reaction. So it's a different form of sequencing. And what you're saying is they're looking at yeast and bacteria and fungus and things like that. But when it comes to dysbiosis, not so accurate a look at the actual bacterial balances.
Yes, that's because PCR by itself is limited in that you have to design primers to identify every single bacteria. But the way we've gotten around that is to identify bacteria by their 16S gene instead, which gives us a sense of the totality of the organism that is in your gut. That is how you get a better sense of dysbiosis versus just looking out for specific bacteria, pre-selected bacteria.
How would you compare to something like Viome?
Yeah, so what Viome shows you, so when you look at Vitract, which that does a 16S test, and Thorne that does a metagenomics test, what we give you a sense of is your taxonomic profile, that is the composition of your bacteria. But and for Thorne, other life forms like fungi and viruses. But for Viome, they're doing metatranscriptomics. Now, metatranscriptomics is it goes away from giving you a sense of the taxonomic profile, that is who is there, to potentially what they may be doing. So they give you information at the RNA level. All of these different techniques of profiling the gut have, of course, their own pros and cons. So it just depends on what you're looking for.
Okay, so back to the Vitract test, I think what would be kind of interesting would be to actually go through my results and use that for illustrative purposes.
Absolutely.
And as we go through that, I think you'll be able to break down what key markers you're actually testing for and what they mean. So you just want to, I'll defer to you as far as the order in which you want to go in. So if you're watching the video version, we got the gut microbiome analysis from Vitract with my results, and hopefully none of my personal details or credit card information showing right there on the screen. So go ahead. Let's go through this, Dozie.
Yeah, absolutely. Yeah. So what you're looking at is Ben's test, and I must say that it was really interesting looking at this, just because we know everybody knows who Ben is. He's his attitude to health and all that. So what I'm going to show you here is what the Vitract report looks like when you take one. So this report is stratified into 4 different sections. The section 1 basically gives you a sense of 2 values here, your gut health score and your diversity score. Now, before I go into that, we say that if you're between 0 and 49, it represents poor. If you're between 50 and 79, needs work. And then 80 to 100 means satisfactory. But what is your gut health score? So here we are basically, everybody starts at 100%. Now, for every single organism that is outside of what we consider the optimal range, which is the range that healthy people who have taken the test actually fall in between. Anything that falls outside that is considered, it would reduce your points accordingly.
Right. Dock you some points every time you find some bad bacteria or an imbalance or something like that.
Exactly.
It looks like my point total is a 78 out of 100.
Yes, 78 over 100.
For overall gut health. Okay.
Yes. And we're going to also get into why that is shortly.
Okay, got it.
And for your diversity score, for diversity, we use the Shannon-Weiner index. So this is pretty much like the academic, one of the academic indexes for calculating your gut diversity score. It takes into consideration two things. One, it is the richness of your gut, which accounts for the total number of species that were found in your gut ecosystem by looking at your sample. But secondly, it also takes into consideration how evenly spread out your species are. So what we mean by that evenness is, say for example, you and I took a gut microbiome test, Ben, and we both have 500 species. But if two species out of the 500 in your own ecosystem makes up 90% of your gut ecosystem, we would not say that is actually evenly spread out. So that impacts on your score negatively.
Right. So you don't just want a wide range of bacteria, but you don't want one or two or a few specific strains to be overcrowding or overpopulating relative to the others.
That is correct.
So at 87 on diversity score. So that's a little better.
Yes, Ben scores 87 here on diversity score, meaning that meaning that he's in the satisfactory range. Okay. So the section 2 of the test here is where we report selected bacteria out of all of the organisms that we have found in your test report. But we have about 30 to 31 organisms here that we select and show on the test reports, because there's only so much you can show on the test report. Another thing you're going to get aside the test report here is actually a full profile of every single bacteria that we found in your gut ecosystem. But why did we select these specific organisms? We selected them because we know so much about them from academic literature on how they contribute to health and disease. Now, in this section, we stratified these bacteria into health-associated bacteria and then the disease-associated bacteria. So we'll start with organisms that are the health-associated bacteria. The first group of those organisms are called the probiotic bacteria. Now, what you're looking at here are the names of the organisms, and then you see the percentage abundance of those organisms in your gut ecosystem. And then you see the implication of, whether or not you're low, you see the implication of that and the implication of high levels of those organisms. The first one here is Akkermansia. So for Ben, it had about 0.1% of your gut made up of Akkermansia. The ranges that we recommend here is between 1 and 5%.
Okay, so my Akkermansia score is low. I actually don't think I was taking the that one you mentioned, the pendulum probiotic at this time. But is that common for someone to have a very low Akkermansia count?
Yes, actually, more than 90% of the people who take the test are actually less than 1% on Akkermansia.
And what do you recommend to people who have a low Akkermansia count?
Oh, yeah. So we know that there's a lot of dietary fibers that actually increase Akkermansia levels. We also have Akkermansia probiotics. So for people that actually have low levels of Akkermansia, the first thing we recommend to them is seed your gut with Akkermansia probiotics, and then you can further feed them with prebiotics that are known to increase the amount of Akkermansia. Bifidobacterium as well is low. We recommend that you should be between 2 and 5%. Ben is at about 0.1%. This is also another organism that we tend to see to be low in most people who have taken the test. Blautia faecalibacterium. And these are very, very important short-chain fatty acid producers. Faecalibacterium, for example, is known to be the largest butyrate producer in the gut. It's an obligate anaerobe. That is to say that it does not grow in the presence of oxygen. But it has a huge metabolic freedom to produce butyrate. That is to say that it can produce butyrate from different dietary sources and has different pathways to actually produce butyrate. We've also seen that this actually makes up, is part of the organisms that make up the largest component of people's gut ecosystem. Ben has it as high as 8% here, which is great. We encourage that you can actually increase it a little bit more in the excess of 10%. But 8% is great. And we should also remember that even if you don't have as high as 10% or more of faecalibacterium, we should remember that there are other organisms that are also producing this short-chain fatty acids. So you can actually have an enrichment of those other organisms that are producing short-chain fatty acids.
Okay, got it. And it looks like it's pretty low as far as my scores go across the probiotic range, is it possible that, even if someone were, say, eating a wide variety of fermented foods, which I do, that other factors could be present that would be causing those levels to be low?
Yes, absolutely. I mean, there's a lot of things that can impact the gut. Diet is definitely a modifiable factor, but other factors like antibiotic intake, stress, your sleep-wake cycle, exercise, all of these things, or even if you're sick or you just have like a condition, all of these things can actually impact the gut.
Or travel. Like I took this test after about 2 weeks of hefty international travel, which I know can impact the gut as well. I even saw one study that kind of equivalated that to the use of antibiotics as far as the amount of dysbiosis hefty amounts of travel across multiple time zones can cause.
Yes, absolutely. This is also what we tend to see in actually my brother's report, who travels a lot. We tend to see that his numbers go back and forth. And when he's more stable, like in his primary location over a longer period of time, we tend to see that things stabilize. So yes, to your point, travel is something that can actually impact things like this, consistent travel.
Okay. Interesting. Got it.
Yeah. Okay. So, but I think that, and I'm going to show that shortly, but I think that what is happening for your report, particularly, Ben, is that you're actually feeding another set of organisms, which I'm going to show shortly, that produce a lot of short-chain fatty acids.
That's all piece of the puzzle. Okay, cool.
Yeah. Okay. Rosoburia is also another short-chain fatty acid. Okay. So here it looks like we need to increase the amount of short-chain fatty acid producers in Ben's gut ecosystem. So that's the first piece of the report, which is the probiotic section. So let's look at the common cells. So these gut common cells are actually these bacteria that coexist within your GIT without causing any harm. You can actually have, large amounts of these common cells, but they play very, very important roles. They help to, create that homeostasis within your intestinal tract. They also contribute to anti-inflammatory state. And many of them also produce very beneficial metabolites. It's not just short-chain fatty acids. They produce things like, neurotransmitters and B vitamins like B12, vitamin K2. This is where most of the organisms that produce them actually fall under.
So would it be fair to say then that like a probiotic bacteria is one that naturally resides in the gut, and a commensal would be something like, I don't know, like an immigrant or even like a beneficial invader who might not be there normally, but who's not doing harm and may actually be helping out with the gut economy or their overall, gut health?
Actually, the common cells are they're pretty much like the probiotic. They are known to be part of your intestinal flora.
Why do you break them out into two separate categories then?
That's a good question. So we break them into two categories because we call this. So these probiotic bacteria are also common cells, except that the common cells are the ones that we know are found in large amounts in the gut. They're known to be found in large amounts in the gut. And then for the probiotic also, we know them to be some of them are bacteria that we can actually buy specific probiotics for. An example being Bifidobacterium and
whereas you couldn't go out and like buy over the counter a commensal and take that as a probiotic.
Like Alistipes.
Got it.
Yeah. Okay. So here we're seeing that Ben is actually optimal on pretty much most of them. So I was talking about what I think is happening with your test result, Ben. I said that I think that you're just enriching another organism that is a very well-known short-chain fatty acid, and that's Coprococcus here.
What did you call it again?
It's Coprococcus.
Prococcus, okay.
Coprococcus, yeah. So this is, there's like 3 to 5 different species of Coprococcus that are known to have huge metabolic freedom to produce short-chain fatty acids, butyrate, acetate, and propionate. And as you can see, I think this is the largest that we've seen in our data set.
Yeah, I'm like off the charts high on that. What would cause something like that to be so elevated?
I think it's just your style of diet. I assume here that I predict here, and I'm going to show you one of the reasons why I predict that also, that you prioritize plant-based, food mostly. So when you look at your common cells, you can also actually predict the style of the long-term style of eating or of diet that someone is actually.
So you're basically, based on what you've seen so far in the bacterial balance, in particular this one that's overcrowding the rest, you're supposing that, not knowing about my diet, that I eat a largely plant-based diet?
This is one organism that allows us actually learn that. It's called the Prevotella here.
Okay.
So you have 28% of that. Now, the gut microbiome, from what we know, can actually be stratified into three main enterotypes. The Bacteroides, the Prevotella, and the Ruminococcus. And these enterotypes basically they give us a sense of, for example, for Prevotella, we know that people that actually have Prevotella to be enriched in their gut ecosystem are people that are prioritizing plant-rich foods and carbohydrates. Whereas people that actually have Bacteroides to be enriched in their gut are people that are prioritizing mostly animal-based diet. So for individuals, for example, who are mostly doing carnivorous diet, it would be super unsurprising for you to see high levels of Bacteroides or high levels of Alistypes, because we know that these organisms are high, they're enriched in the presence of high fat foods.
Yeah. And by the way, I'll just come right out and tell you right now, I'm pretty much omnivorous. I eat a lot of meat, red meat, poultry, fish, pork, organ meats, and a wide diversity of plants, sprouts, microgreens, ferments, etc. So I would not categorize myself as a largely plant-based individual.
Yeah, I think for your results, actually, it also kind of like suggests to us that you're rounded up because you have high levels of Bacteroides. So what we tend to see is people who are on the extreme of maybe carnivores, we tend to see just super high levels of Bacteroides. And then people who are primarily just like vegan, we see super high levels of Prevotella. But what we are seeing here for your result, you have about 5% of your gut made up of Bacteroides and about 28% of that made up of Prevotella. So that's pretty much balanced in terms of just looking at your gut microbiome profile.
But that one that's super high that you said you tend to see super high and people are eating a lot of plants, do you think that's potentially detrimental or something I should be paying attention to or doing something about?
No. Actually, this is we know that these organisms have what we call the starch utilization system, which is a group of pathways and enzymes that allows them break any kind of carbohydrate. So this is actually a good biomarker versus not. So you're completely fine here.
And one of the quick questions before we keep going: how much does this fluctuate? Like, if I were to do one test on a Monday, another test next Tuesday, another test a month later, like, does it vary quite a bit?
Yeah, so it depends. The microbiome actually fluctuates across two different time scales. I don't think the word I should use there is fluctuate. So it fluctuates on a short-term scale. There are certain organisms that can fluctuate on a short-term scale, but on a long-term scale, the organisms that actually are most stable are these organisms that we've been talking about, the Prevotella and the Bacteroides. They are enriched based off on your long-term diet. But on the short term, you're definitely going to see some small changes in the distribution of your gut microbiome. But it's not anything. It's not anything huge when you're looking at Bacteroides and Prevotella, which are the main enterotypes.
Okay, got it.
Okay, so it looks like you're optimal for every single bacteria that is on the commensal section, which is
I was pleased to see that. Like those are all pretty well balanced.
Yes, which is great. That suggests that you're keeping an anti-inflammatory state. You're producing your gut bacteria are producing beneficial compounds and metabolites like your vitamins, your neurotransmitters, etc. Okay. The third section is what we call the Pathobionts. So these Pathobionts are organisms that, when they're in your gut in small amount, you're completely fine. Or when they're absent, you're fine. But they tend to pose a problem to your gut health when they overgrow. And this overgrowth might be as a result of, intestinal dysbiosis or, a long round of antibiotics regimen. that potentially just wipes out the beneficial organisms in the interim, that can actually lead to the bloom of these pathobionts, especially the ones that are antibiotic resistant. All right.
And those are just for anybody who didn't pick up that term. It's pathobiont, Pathobiont. These are the ones that you don't want to overgrow.
You don't want them to overgrow. So if you have them in small amounts, you're fine. Or if you don't have them at all, you're fine. And here, you're actually optimal in almost all of them, except for proteobacteria. Now, this is also borderline high because we recommend 0 to 4% here, and you have 5% here. And here, we know that these proteobacteria are pretty much gram-negative bacteria that, if you look at the outer covering of these bacteria, they have what we'll call the lipopolysaccharides. And these lipopolysaccharides are made up of lipid and polysaccharides. We've known for over 3 to 4 decades that these components of the bacteria are highly, highly pro-inflammatory. So this becomes a problem when you have an increased intestinal permeability. For people that have a leaky gut, what happens is that when they have high levels of proteobacteria, those bacteria tend to translocate from places like the gut lumen across to the epithelium, and then they can actually incite complex immunological reactions, which sets the stage for inflammation.
So a high pathobiont count in that case could be indicative of the presence of leaky gut or a permeable gut lining.
Yes, it could be indicative of that.
So I should be checking out my bowel movements to see if I have any spinach or corn or carrots or seeds and nuts in there to see if stuff's going through or not, right?
Yeah, but I think also the most important thing there is, think about the gut as an ecosystem where all of these organisms are competing for everything, resources, space inclusive. So what we tend to see is that when you increase the amount of your probiotic bacteria, which some of which you're deficient in, you automatically see a reduction in these proteobacteria. And how does that happen? A lot of these probiotic bacteria produce things like butyrate, and we've seen in academic literature that butyrate actually plays a huge role in sequestering lipopolysaccharides. So that's one way that's actually one smart way of driving down levels of proteobacteria. It is by increasing the amount of your beneficial organisms, such as your probiotic bacteria.
Okay. Yeah. And that's achieved through, I know, a wide variety of fiber containing foods to elevate that butyrate count. Okay.
Exactly. Yeah. And then for other things like hydrogen sulfide producers, we have organisms like Bilophila, Wadsworthia, and Disulfovibrio. These are pretty much sulfate-reducing bacteria. And Bilophila, the name gives it away. It's a bile-loving bacteria. It degrades bile to produce hydrogen sulfide. Disulfovibrio is also a hydrogen sulfide producer. One of the things that we encourage here is when you have high levels, we encourage that, you want to keep this almost non-existent or super low, because an overproduction, an overaccumulation of these organisms can actually lead to an accumulation of hydrogen sulfide.
Right. So you get almost like small intestine bacterial overgrowth like symptoms like SIBO, gas, bloating, things like that, if those were elevated.
If those are elevated, more like they cause an impact in your large bowel, which can, of course, then impact your upper bowel, in which case you're talking about your SIBO. Yes.
Well, I'm glad mine aren't elevated then.
0. Completely 0.
Cool. Good.
Methanobrevibacter is another one. You have 0. These are methane producers. We actually see this with people who are dealing with chronic constipation. And we've also seen this in people who have constipation predominant IBS. And when you think about it, that makes sense, because Methanobrevibacter, a very popular species of it is Methanobrevibacter smithii, produces methane. And we know that methane actually contributes to the slowing of the transit time of food across your gastrointestinal tract.
All right, good. I'm not producing a lot of methane. I'm not a cow. Great. I actually don't really fart that much, so maybe that's a clue. All right.
Okay. Enterococcus E. coli 00, which is great.
Good. No E. coli.
Okay. Now, exogenous pathogens. So exogenous pathogens are bacteria that are not part of your normal flora. If you find them there, especially in high amounts, it means that you've actually picked them up from the surrounding. An example is Campylobacter, that is very highly implicated in food poisoning. Shigella contributes to dysentery, Salmonella, Staphylococcus vibrio, Yersinia, all of them, you have them at 0. So that's fantastic.
Great.
Okay, so that's section 2. Section 3, here, we're giving you insights into the metabolites that are produced. So here, again, we are not measuring the metabolite. 16S cannot measure metabolite, but we're basically just showing you the proportion of organisms that we know produce this metabolite. Here, we start by showing you short-chain fatty acid producers, butyrate, acetate, and propionate. So for butyrate and acetate, it makes sense because if you look at the previous result that we went through now, we saw short-chain fatty acid producers to be low. That's why your score here is 41 and 48. And just to elaborate, what you see here, the metabolites, what you see here, your percentile score, pretty much how you compare to other people who have taken the test. And here you're seeing the associated impact.
So still showing an elevated need to get the short-chain fatty acids in the gut elevated.
That's correct.
Got it.
For neurotransmitters, everything checks out. Organisms that produce dopamine, GABA could be higher. This is also not to, and this is, I think this is important. This is also to say that if your values are low here, it doesn't necessarily mean that you're actually deficient in GABA and dopamine. We're just looking at the microbiota contribution.
Right. But it's a good glimpse into a predictive analysis of the gut-brain axis as far as the neurotransmitters that are potentially being created as metabolites in the gut.
Yes, it is. And so we show neurotransmitter producers. For vitamin producers, you actually check out outstandingly on all of them. Vitamin B1 down to K2, you're all in the satisfactory range in the 70s and 80s. Here we have the toxin producers. Here you want your values to be closer to 0. So for you, hydrogen sulfide, that makes a lot of sense because you don't have those organisms that produce hydrogen sulfide, as we saw. Ammonia, 57. Here we are basically looking at, organisms that are known to metabolize proteinous foods to produce ammonia. And your 57 there, that shows needs work. Methane, you're good. You're actually like in the first percentile. That's wonderful. LPS, that makes sense because we've seen that your proteobacteria, you actually have about 5% of your gut to be proteobacteria.
Okay, got it. Quick question on the ammonia piece. You didn't see that elevated, you said, for example, with the metabolizing of meat. Is there, or maybe you're getting to this on your recommendations, if so, you could just shut me down and save it for later, but is there a way to actually modulate or lower that value?
Yeah, one way that we tend to reduce that is we tell people to go down a little bit on animal-based diet. Okay, so detoxification markers, great, and longevity factors. So here we are basically just looking at the organisms that, for example, we're looking at myrosinase. We know that there are certain bacteria that actually have, the myrosinase enzyme that helps to break things like glucosinolates to isothiocyanates, which have, anti-inflammatory properties and anti-cancer properties.
Right. Those are the ones you'd find in high amounts in like sulforaphane and broccoli sprouts and things like that.
Exactly. And cruciferous vegetables. Exactly.
And you said mine were a little bit low, or I could increase my intake of things like cruciferous?
Yes. So you could increase. Yeah, that's a good point. You could increase that. That could help to enrich the organisms that break that down.
Okay. Got it.
Yes. Yeah.
And by the way, real quick, back to the ammonia piece, just something I was thinking about after you said that about meat. Is part of it improper digestion of meat? Like, could it be related to like low pancreatic enzyme production or poor meat digestion versus overall meat intake? Because again, I don't eat a ton of meat. It's part of my diet, but I don't eat, I'm not nowhere near my carnivore friends intake.
No, absolutely. Yeah, it could be that. Unfortunately, we can't just account for that using a test like this.
Yeah. Okay. Got it.
Yeah. Okay. So that is the section 3. And the last piece is the section 4, which is where we basically show you recommendations. So based off on what we saw, what should you be eating and what shouldn't you be eating? And these recommendations, I must say that they're purely based off on what we know in academic literature. And so here we're seeing things like, and we stratify the recommendations into foods, probiotics, prebiotics, supplements, and lifestyle changes, right? So here we see that, Ben should be taking cranberry. Why? Cranberry, rye, and cherry. But why should he be taking those? Because those three recommendations increase akkermansia. Right?
Cranberry, rye, and what was the other one you said?
Cherry.
Cranberry, rye, and cherry. Okay, so if you're going to take an akkermansia supplement, if you included cranberry, not just on Thanksgiving, folks, rye, I'm assuming like rye bread, rye crackers, and things like that, and cherry. I love tart cherry before bed, by the way. It helps with sleep. That would increase akkermansia.
Akkermansia, yes.
Okay, that's interesting.
And we show all the scientific evidence that actually back that up.
Yeah, you've got all the studies listed there. Okay, got it.
Exactly. And we do the same. So that's the approach. So we start out by just showing the things that are low and high, and then all these recommendations just attend to them. Yeah.
Okay, that's super helpful. What are some of the highlights on the recommendations that you think are the most critical or important based on what you saw in my test?
I think some of the most critical things here are we want to get akkermansia up. One is we've shown how cranberry, rye, and things like cherry can increase akkermansia, but also probiotics that can increase akkermansia that are not akkermansia probiotics are Enterococcus faecium, Lactobacillus kefiri. We've seen that in academic literature that by supplementing with those probiotics, you can actually indirectly increase the levels of your akkermansia.
Did you call it Lactobacillus kefiri, like what you'd find in kefir?
Yes.
Oh, interesting. Okay.
Yeah.
Well, I know how to make that. I usually use it as a meat marinade, but I can start drinking more of it. So that's good to know. Okay, got it.
Yeah. And then for supplements, you see things like sulforaphane, which makes sense because we were just talking about the myrocyanase, or bacteria that harbor myrocyanase enzymes. We know that myrocyanase helps actually to break down things like glucosinolates to sulforaphane. So here you can actually supplement with sulforaphane. And we know that by supplementing with that, you can reduce bacteroiditis because you're already high in bacteroiditis. So anything that you see here to be reduced are things you're already high in.
Well, my wife and I have really been getting into making sprouts a lot. We actually weren't that into it prior to when I had taken this test. When we just got some new sprouting kits from the sprouting company, and I've actually already increased my sulforaphane intake pretty significantly just by having sprouts with just about everything except maybe breakfast.
Yeah, that's actually something that we started in this house like literally last week.
Yeah,
as well.
So easy and so cheap compared to buying them from the grocery store.
Yes, exactly. Yes. Okay, and lifestyle changes. We see these are some of the things that we recommend: high fiber diet, fruits, legume fiber, and we show why you should be including those.
I mean, would you ever not recommend that? Would you ever see something where you'd say, hey, back off the fiber or don't eat as many plants? I mean, it seems like that's just generally a broad recommendation just about, I mean, but besides like an autoimmune issue or an elimination diet, for example, which you're no doubt familiar with, that's why some people will follow the carnivore for a short-term stint to manage some autoimmunity flare-ups. But for the most part, I'm assuming you're recommending that to just about everybody, the plant and fiber intake.
Yeah, it's a good point. It's one of the things that we have consistently seen to actually have more. It has more. It impacts more health benefits than not. So
yeah. Okay. Got it.
Yeah. Okay. Yeah. So Ben, this is what your test result is, and for people who are interested in digging a little bit more, they want to look at all the references, where the recommendations are coming from. We also show them those in the supplementary tables.
Okay. Cool. I have a few follow-up questions. The first is, and I've been asked this before by people, I think related to 16S sequencing. Is there evidence that when you implement these recommendations, that you can actually shift this profile significantly? Like, do you take a group of people, do the 16S sequencing, implement the results, come back, do the sequencing again, and see actual change?
Oh yeah, absolutely. There are actually studies, and the way these studies have been set up is you pretty much have two groups of people. You give you test them prior to when they actually start the interventions, and then after they do the interventions for 8 weeks or 10 weeks or thereabouts, you then test them again, and there are lots of studies that actually show dramatic changes between those two time points.
Okay.
So yes, and we work with clinicians who are already using this test. This is the way they use it. It's more like they use it longitudinally. They test their patients prior to giving them the interventions, and after 3 months, they test again.
Okay. And then as far as the butyrate and the short chain fatty acids, let's say someone were eating a low fiber diet because they have gut issues or they have FODMAP sensitivities or maybe some type of autoimmune issue. Is there something to be said for the use of like butyric acid supplementation or some other approach that wouldn't be so hefty in fiber to increase short chain fatty acids?
Yes, absolutely. Absolutely. So in that case, supplementation with, butyrate supplements makes sense, like BHB and the rest, because we know that people who are dealing with IBS issues can't withstand high FODMAP foods.
And I could be misremembering this, but does coconut oil or coconut products, do they have an impact on short chain fatty acids?
Yeah, they do.
Okay, so if you were, I don't know, let's say you're eating a carnivore diet, you could include things like butyric acid supplementation or coconut oil and elevate levels of short chain fatty acids higher than what they might be on a non-fiber diet.
Yeah, but that's the thing. The goal is, yes, you can do that, but the bigger goal is to actually want to arm your resident bacteria to be able to produce these things rather than doing like a continuous supplementation. But when you need to, in situations like this, yes, it makes total sense to supplement.
Okay, got it. The next question, kind of a logistical one. I test so much, I don't remember. Is this just like a tissue swab on the butt after you poop, or was this the one where you got to fill up a bunch of tubes? Remind me of the logistics of the test.
Yeah, so we send you the kit home, and then you basically collect your sample on a tissue paper, and then you take a swab stick to just pick a sample.
So it's a very small amount compared to like the Genova Diagnostics GI map test where you're filling out like, I don't know, like 4 to 6 tubes, if I remember properly.
Yeah, that's because they are, like for Genova, for example, they are also kind of like processing part of the samples using different other techniques. So they need a large sample size.
Yeah, so way less performance anxiety, folks. You just got to wipe and you don't have to hover over the toilet and try to fill up everything. So that's good. And then another question about this. If someone tests in terms of their results, obviously they get a PDF. I don't want to give people the impression you're going to hop on the phone for an hour with everybody who gets results back in, but how do you guys approach the process of interpreting or walking people through their results?
Yeah, that's a very good question. So we actually have about 50 active clinics now that are using the test. So one of the services that we also provide is when people take the test and they are interested in working with a practitioner, we can actually link you up with one of our practitioners who can help you walk through the results and give you more insight into your profile.
Yeah, the PDF is pretty helpful, but I know some people might want a deeper dive walkthrough like we're doing right now. And then as far as the cost of this test, how does it compare to other gut tests in terms of the investment?
Oh yeah, so the test currently goes for $150 US. For people in Canada, it's 210 Canadian dollars. And one of the reasons why is that we have prioritized affordability is because just coming into this space, we've seen that that's a major pain point. These tests are out of pocket, and people, you get better value from this test when you can actually retest after trying out the interventions. So $150 USD, 210 Canadian dollars.
Okay, got it. And when you were going through the vitamins and the metabolites related to vitamin production, have you ever yourself or seen someone go out and get a blood test and see, for example, for, I don't know, vitamin D or something like that the results correlate? Like if you have low vitamin D metabolites, that you'd also have low, like 1-hydroxy vitamin D levels in the blood or something like that?
That's a really good question. For vitamins, no, but we've seen that with short chain fatty acids. We've seen that with people who have done the test super low on short chain fatty acid producers, and then they do another, metabolomics test that actually, measures and quantify the actual metabolites in their fecal sample, and that correlated with the low levels that they saw in our test.
Now, in your lab, with everything you know about gut and gut testing technology, are there any up and coming technologies or tests or research that you're particularly excited about?
Oh yeah, that's a good question. Yeah, I'm excited about where the gut microbiome is going. I think that all of these different techniques that we're using now is telling us part of the story, which is great. But in my opinion, I think that where we are actually going to get a full appreciation, especially in the context of dysbiosis, is when we can merge more like whole genome sequencing and metabolomics. But the problem now is cost. So, as there is more adoption, what we envisaging is that in the near future, the cost will really go down, and then we can actually, combine those kind of two powerful techniques to really understand the gut microbiome.
Okay, got it. So let's summarize it. There's 4 different sections of the test. You're looking at the probiotic bacteria, the commensals, the Pathobionts, and then the what was the last one?
The recommendation.
Yeah, the recommendation section where you see which foods to eat, which lifestyle factors to adjust. And then in terms of, for example, for a guy like me, you're seeing, despite me eating a widely varied omnivorous diet, inclusive of fermented foods, that travel might have had an impact on the gut biome, that I personally need more Akkermansia and more short-chain fatty acids. I may want to look into my enzyme production to see how good a job I'm doing breaking down the meat that I'm consuming. And I should increase my sulforaphane intake from cruciferi, broccoli sprouts, etc. And then for the Akkermansia piece, in addition to looking into something like an Akkermansia probiotic, cherry, rye, and cranberry.
Right. That's correct. That's a wonderful summary, actually.
Yeah, it helps me a lot to be able to just summarize things in 30 seconds, so I don't have to, go up to the refrigerator and Instacart and Amazon and, order 100 different things I don't need. So this is super helpful. Well, I'm going to include a link to Vitract in the show notes. I believe we have a discount as well on the testing. And so you can go to bengreenfieldlife.com/Vitract podcast, VITRACT podcast. You can leave your questions, your comments, your feedback there. If you have your own gut questions or more questions about how this test works, how it compares to others, just go there and leave them all. And Dozie, thanks so much for doing this, man. It's been super interesting and insightful.
Thank you very much, Ben. Thank you for having me on your podcast as well. It was a good talk.
Yeah, absolutely. It's my pleasure. All right, folks. Well, I'm Ben Greenfield, along with Dozie from Vitract, signing out from bengreenfieldlife.com. Have an amazing week.
Do you want free access to comprehensive show notes, my weekly roundup newsletter, cutting-edge research and articles, top recommendations from me for everything that you need to hack your life, and a whole lot more? Check out bengreenfieldlife.com. It's all there. bengreenfieldlife.com. See you over there. Most of you who listen don't subscribe, like, or rate this show. If you're one of those people who do, then huge thank you. But here's why it's important to subscribe, like, and or rate this show. If you do that, that means we get more eyeballs, we get higher rankings, and the bigger the Ben Greenfield Life show gets, the bigger and better the guests get, and the better the content I'm able to deliver to you. So hit subscribe, leave a ranking, leave a review if you got a little extra time. It means way more than you might think. Thank you so much.